Okay, here we go. Just so you know, for your Unit 2 test, we learned two ways to find a vertex, right? You can change it from standard form to vertex form. You can pick off a vertex. Then we learned another method called partial factoring. On the test, you'll have questions that'll say, find the vertex using changing to vertex form. So you have to change from standard form to vertex form. Or you'll have find the vertex using partial factoring. So you have to use the partial factoring method. But if you have a question where you need the vertex, it doesn't say what method to use, you can use either method. Okay, it's your choice. Okay, I just wanted you to be aware of that, okay? So remember, in this kind of questions, it doesn't say write in vertex form first, so we don't have to. You could use partial factoring if you find partial factoring easier. Two numbers have a sum of 25. Find the numbers if the sum of their squares is a minimum and state the minimum. Okay, so you need a let statement whenever you're doing application problems. Always remember, as soon as you see something that, find the minimum, find the maximum, you need the vertex form. You need that form, right? You need vertex form. As soon as you see that or you see maximum, right away you need to find the vertex form. This is going to go blurry just for a bit, and then it doesn't seem clear to me. Oh, that's better. Well, I think it's my glasses. It's not there. Okay, so let the two numbers be x and y. Oh, I thought of y too soon, but this should be an and. And there. Okay, there we go. This should be and y. So that's half a mark on a test, right? You want all those half marks, full marks. Now they tell us the two numbers have a sum of 25. Sum means adding, so x plus y equals 25. They also tell you that the sum of their squares, so I'm just going to, is a minimum. I'll just call it minimum. M equals x squared plus y squared. They say it's a minimum. Okay, so we can't work with x squared and y squared because that's sort of our dependent variable. X is our independent variable. So we have to solve for y here. Y equals 25 minus x, and we're going to sub that in. So we have x squared plus 25 minus x all squared. So we're going to have to FOIL and collect like terms. X squared plus 625 minus 50x plus x squared. Does anyone need me to show how I got this to this? I just FOILed, right? Everybody, if there's anything you want me to explain further, please let me know. So we have 2x squared minus 50x plus 625. Okay, so now we have an equation in standard form, but since we want to pick off the minimum, we need a vertex, so we're going to write it in vertex form. So we're just going to factor out a 2, x squared minus 25x. We'll leave some room here for completing the square, and we'll leave that 625 out there. Okay, so we have to have and square the coefficient of the middle term. So it's 25, have it, square it. So that's going to be 625 over 4, right? So we have to add it inside the brackets and subtract it inside the brackets. Okay, so I want to get this one out of the brackets so I don't interfere with my perfect trinomial square. So we have 2x squared minus 25x plus 625 over 4. So it's going to be minus 2 goes into 2 once, 2 goes into 4 twice. So it's minus 625 over 2. And we need a common denominator before we can add that. So over 2, that will be 1250. Right. 2 times 5 is 10. Carry 1. That's 5. 1250. Okay. So now we can factor our perfect square trinomial. This is 2 times x, that's a minus, square root of that is 25 over 2, all squared, plus 625 over 2. So now we have an equation in vertex form, so it's easy to knock off our equation, or just get our equation. Right? So, what is our minimum sum of squares? What's our minimum value? Is what? What's our minimum? Right? It's opening up, so we know the vertex represents our minimum. What is our minimum? Yes? Our minimum y value, sorry, can you say that again? That sounded like an awfully long answer. Anyone want to? Perfect. I just heard a very long answer, but it's just 625 over 2. Right, we pick it off right off, because this represents our minimum sum of squares, so that's our y value there. And the two numbers are what? Our two numbers are, well, we pick off one of our numbers here. Our x value is 625. No, sorry, 25 over 2. And so our y value is, we're going to use our formula, 25 minus 25 over 2 equals 25 over 2. So there are our two numbers right there. Okay? I'm just showing you the work here. You don't have to do. But notice, usually half a mark for let, usually half a mark for a proper conclusion. Can I explain anything better? Anything at all? Sorry? Sorry? Do you see how I use this formula? So I know my x value is 20, so y equals 25. The x value I found was 25 over 2. So that's 50 over 2 minus 25 over 2, and that equals 25 over 2. So both the x value and the y value is 25 over 2. From the vertex. Right there, that little guy right there. I got it right there. Because my minimum occurs when x equals 25 over 2. So now I can use my x at 25 over 2 to calculate my y value. Anything else I can answer? A rectangular lot is bordered on one side by a river and on the other 3 sides by 320 meters of fencing. What is the maximum area? Okay, so we have a river. There's a river. And all they're trying to tell you is that only 3 sides require fencing because of the river. So we'll call this width, length. So you say, let the variables be as shown in the diagram. And I will be happy with that. Or you could say let the width be W and let the length be L. And so here they got 320 meters of fencing, so you know that 320 equals, well, you have two widths plus a length. So we can solve for the length. Length equals 320 minus 2W. Can I explain anything better? Anything at all? So now our area equals width times length. Our area still equals width times length, right? So we have here width times 320 minus 2W. I'm just going to put the W squared first, so minus 2W squared plus 320W. So again, when it says maximum, do you want to just, why don't we do an example where we use partial factoring method? See, there's no value here. Already we can just factor that. There's just two terms. That's ideal for partial factoring. Let's give it a try. So we're going to take out, now you know what, I prefer vertex form. I'm just going to, because we're sort of set up with the A equals. Well, no, okay, we can go let A equals 0. So 0 equals minus 2W squared plus 320W. 0 equals negative 2W times W minus 160. So 0 equals, no, sorry, W equals 0 or W equals 160. You get it there, right? Well, this is not true because width cannot equal 0. If width equals 0, you don't have a rectangular lot. Therefore, W equals 160. Something here. It's kind of like this can't be 160. This has to be 160. So I'm not sure what happened. Right? Do you know what I mean? This can't, both of these can't be 160. I'm just not sure at this point what happened. So can you guys do me a favor just for now, while I figure this out? I'm not going to do it now. I just want to cross it out right now. I don't like the way where this answer is going, so I'm just going to change this to vertex form. So this, we'll just factor out the negative 2 minus 160W. So I just cross that out. I don't like where it's going, and I need to look at that. I find that odd, but I'll look at that later on today. Okay, so we have to complete the square. Okay, so go 1/2 times 160 and square it. So that's going to be 80 squared equals 6400. So we have to go plus 6400 minus 6400. We added and subtracted inside the brackets. Let's kick that guy out. And we're going to have to multiply that by 2, so that's 0, 0, 12. 12,800. So now we can answer our questions. Well, let me factor this. Square root of the first term, that's a negative. Square root of that is 80. Do you see what I mean? Here we get a W of 80, right? When we pick it off the vertex, here we get 160. That really kind of baffles me right now. So our answer to I is max area is what? Right? We get it from our vertex, 12,800 meters squared. Yes, thank you. Thank you for that. Okay. So, and our width is equal to the width is 80 meters. And what is the length? The length is what? Can anyone tell me? 160 meters. Does everyone know how I got 160? No? How did I get 160? I'll do my rough work here. I use this formula. L equals 320 minus 2 times 80. So that equals 320 minus 160, and that equals 160. That's how I got the 160 meters. Good? Is there anything I can explain better? Now this question here, you need to use a calculator for. I realize that on this test, remember it's a no calculator test. But I want you to see an example of this, okay? The fuel consumption of a car in liters per hour can be expressed as this equation for a velocity between 10 and 100, where C is the fuel consumption, V is the speed. What is the minimum possible fuel consumption? At what speed does this minimum occur? Okay, let's do it. You know right away we need to do find the vertex. So we have C equals 0.05 V squared minus 6V plus 187. Now we're going to factor out the 0.05, so negative, well that's V squared. Negative 6 divided by 0.05 is actually 120V. We'll leave room for completing the square. That's plus 187. That's an 8 right there, okay? So we're going to have the negative 120 and square it. So that's going to be negative 60 squared, and that equals 3,600. So we go plus 3,600 minus 3,600. So C equals, we'll kick that guy out, 0.05. V squared minus 120V plus 3,600. 0.05 times 3,600 is minus 180 plus 187. So C equals 0.05. The square root of that is that's a minus. Square root of 3,600 is 60 plus 7. So right away, what is the minimum possible fuel consumption? 7. Yes, but don't forget your units. minimum fuel consumption is 7 liters per hour, right? Though units are important, that's because it doesn't make sense. It could be gallons per hour, liters per hour, unless you tell the reader they don't know. And it occur at what speed does this minimum occur? It occurs at 60 km per hour. May I explain anything better? Anything at all? Please practice, 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 practice. Repetition is the law of learning. A movie theater owner wants to increase his ticket. Ooh, he wants to, of course, everybody wants to increase their prices. Figures. They are presently $6, and research tells him for every dollar increase in price, he will lose 50 customers. This theater sits 500. Okay, so let us see. You know that revenue equals price per ticket times number of tickets sold. Okay, so the first thing we have to do is say let X be the number of price increases, because he's increasing, right? If he was decreasing, we'd say the number of price decreases. So revenue equals, well, his starting point is his theater sits 500 and his starting price is 6. So you start with your starting. Now he wants to increase by $1, right? So we're trying to find out the number of price increases of $1, and for every price increase he loses 50 customers. So now we have a quadratic equation. Sorry? So we go 6 times 500 is 3,000 minus 6 times 50. 6 times negative 50 is negative 300x plus 500x, and that's going to be negative 50x squared. So that's negative 50x squared plus 200x plus 3,000. So notice it's a negative. A is negative. Right away you know opens down, and your vertex will represent a max, right? Let's factor out the negative 50. So far so good? Complete the square. We are going to go, my little post-it note, have the negative 4, square it. Having and squaring is the play. So that's going to be negative 2 squared equals 4. So we add 4, we subtract 4. Now we got to kick out that negative one because our trinomial square, our perfect square trinomial is there. So it's minus 50 x squared minus 4x plus 4. Negative times the negative is a positive. 4 times 50 is 200 plus 3,000. Let's simplify this. Negative 50 will factor our perfect square trinomial. Square root of x squared is x. That's a negative. That's square root of 4 is 2 squared plus 3 200. Max revenue is $3,200. 2. Let's see. They get find the ticket price. This has to do the ticket price. How many price increases does he want? 2, because x equals 2. Right? I'm just going to maybe, so you realize the vertex is 3,200, right? That's our vertex. So it occurs when x equals 2. So our price is going to be 6 plus $1 times 2 is $8. How many people? Well, let's calculate it. The number of people or the number of tickets sold is going to be people or number of customers is going to be 500 minus 50 times 2, and that is going to be 400 customers. So, any questions? Any questions? No? Okay, I'll sign off and I'll